Welcome to all of you. Today we will discuss the another technique of machine learning and its implementation by using Python programming.
Now let us discuss about the hierarchical clustering. Basically, in hierarchical clustering we are having a two-way through which we can perform the clustering. One approach is agglomerative clustering. So basically it uses the bottom-up strategy to form the cluster. Another strategy is divisive clustering, which basically uses this top-down strategy to form the cluster. So that is a two different way through which we can perform this hierarchical clustering, right? First one is a divisive, that is a top-down approach, and this agglomerative, that is a bottom-up approach. Now, concern is why we are using this hierarchical clustering. Since already we have used this k-means clustering, then what was the reason why there is a requirement of some other clustering technique? So that firstly we must understand. Then we can see what a way this hierarchical clustering has overcome those issues, which was the demerit of k-means, right? So let me tell you one thing. If you recall, in k-means we used to give us such kind of data set. In such kind of situation, k-means beautifully perform, right? Here we were having a 4 cluster. So if you give this 4 value, k value is equal to 4 to this data set, it beautifully find out this 4 different clusters. So if you recall the k-means, basically the idea behind that, we randomly start with some centroid, and from that centroid we used to calculate the distance, right? Maybe the Euclidean distance or Manhattan distance, right? And this k-means was a iterative process. So if you run the algorithm, ultimately converge the result like this, right? So in such kind of situation, k-means was a wonderful choice, right? Where it will give you the beautiful result. But again, there is some demerit of k-means. Suppose if you want to give such kind of data to k-means clustering, so obviously in this data set there are two concentric circles are there, right? So if you pass this data to k-means algorithm and k value is equal to 2, then answer of that used to come like this way, which is not correct, right? Similarly, if you are having this this banana shape of data, if you pass this data to k-means clustering algorithm, again this used to give this unexpected result, right? So basically, in other words, if I will say, this k-means basically fails in such kind of situations. That's why there is a need of some other alternatives. So one of the alternative is this hierarchical clustering. Now in hierarchical clustering, we are having the different way through which we used to calculate the distance. Let me tell you how basically it works. So in divisive clustering, as I told you, it is a top-down strategy. The starting point is the largest cluster with all the object in it, and then we split it recursively to form a smaller and smaller cluster, right? It basically terminates when the user defined condition is achieved or final cluster contain only the one object. Whereas in agglomerative, it uses this bottom-up approach. It starts with each object forming its own cluster and then iteratively merge the cluster according to their similarity to form the large cluster. So let me tell you this agglomerative clustering first. So here, let us firstly understand actually what is the math behind it. So in agglomerative clustering, you may find out the distance. You can calculate the distance by using single linkage, or complete linkage, or average linkage. So let us first understand what is the meaning of this linkage, right? Let's say this is a data point which we are having with us. So there are let's say 6 data points we are having. These are the coordinates which is given to this data point respectively. Now see, how does it work? Basically, as we know, we have to find out the distance. Actually, the idea behind this hierarchical clustering is we have to find out such a point which are very close to each other, right? And then we merge such a point together to form a one of the cluster, right? So by using this principle, we have to be, this algorithm is move around this principle. So what we are doing over here, we were having a 6 point. Now what we want to find out, we want to find out the distance from each point to the other remaining points, right? So P1 to P1 is 0, P2 to P1 is 0.23. Now concern is how to calculate this distance. Basically this distance we calculate by using this Euclidean distance formula. So the P1 coordinate, x1 coordinate was 0.4 and P2 x1 coordinate was 0.22. So x1 minus x2 whole square plus y1 minus y2 whole square. If you solve it, the answer is what? 0.23. So by this principle, we used to calculate the distance of P1 and P2. Similarly, we have to find out the distance between P3 and P1, P3 and P2, P4 and P1, P4 and P2, and subsequently the other values. So if you calculate it, because we are knowing the coordinate of all the data points, simply we will use this Euclidean distance formula and we solve it one by one, and after solving you will get this matrix, right, which is basically having a distance from one point to the other remaining points, right? So P2 to P1, this was a distance, P3 to P1, this was a distance, subsequently other distance measure we are having in this matrix. Now let's start how this this principle of hierarchical clustering works, right, in case of agglomerative. So here basically we try to merge those points which are very close to each other. So if you observe this matrix, the minimum point is coming with respect to this P6 and P3. This value of this is 0.10, which is minimum among all this distance, right? So the thing is, now we have to merge this P6 with P3, right? That is the first cluster which we can form like this. So now after forming this cluster, the second step is again from that cluster, from the remaining data points, again we have to calculate the distance, right? So the same thing we are doing over here. We have formed one cluster by combining this P3 and P6. Now from this cluster, again we have to find out the distance from the other remaining point like P1, P2, P4 and P5. Now this linkage basically differ from each other based on the distance, how we measure the distance. For example, here we have to find out this P3, P6 from, distance from P3, P6 to P1, right? So this distance we can measure like this. Firstly, we'll find out the distance between P3 and P1 and P6 and P1, and among this we will take the minimum, right? So this is how your single linkage work. It basically find out the minimum distance from these 2 points, right? So this values already we are knowing. P3 to P1 distance already we are knowing. P3 to P1 is 0.22. So this value we have kept over here, and P6 to P1 is 0.24. So among these two value, it basically find out the minimum. So minimum will be what? 0.22. Same thing we have done with the P3, P6 and P2, right? Again here we have to use this minimum only because we are using this, we have to remember this, we are using a single linkage, right? This thing will change if you will go with some other linkage method. So that is only one difference which will make the result differ from each other. Okay, so like this way we have calculated the distance of this cluster from the remaining point. So this is the updated matrix, right? So this P3, P6 cluster we have make a single cluster. This 2 point is forming a one cluster, and this is the updated matrix which we are having. Again the method is same. We have to find out the minimum value among this. So again, what is the minimum among this? If you see this, if you observe this value, this is the minimum distance 0.13. It means the new cluster, this P4 point is very close to this P3, P6 cluster, right? It means now we have to merge this P3, P6 with P4, right? That is the idea. So now the next thing is we have to merge this P3, P6 with P4, right? Now they are forming a one cluster. Again, the step is again from this cluster we have to find out the distance from the remaining point. Same thing we have done by using this step, right? One thing only we should remember, every time we are calculating the minimum distance, right? Because it is a single linkage. So this value already we have found, so that value we have put it over there, and again out of this two we have to find out the minimum. Like this way we have updated this matrix. Now again the same procedure will keep going. Again, out of this we have to find out the minimum. So minimum is 0.14 with respect to this cluster and P2 as well as P2 and P5, right? Both are having the same value. Now we can we can form them the two different cluster. So this is going to be combined with P2 and this P5 is going to be combined with P2, right? So again we have find out that this value is minimum. That's why this P2 and P5 we are putting together, and this was another cluster, right? Again the same thing we have to keep doing. We have to again find out the updated distance from this cluster from the remaining point P1. So this is the updated matrix which we are getting. Now again here if you observe, this is the minimum value. It means this P2 P5 cluster is going to be merged with the P3 P6 and P4 cluster, right? If you do this, this will be the updated value, right? And finally the algorithm will tell you that this is the this is the dendrogram which basically represent how this cluster formation has occurred. So in the first step, this P3 P6 we club together, and then we have clubbed this value with the P4. Then P2 and P5 we have clubbed together, and this value is nothing but the distance, right? And then finally we have to club these two, and likely the whatever resultant are coming, this P2, P5, P3, P6, P4 is going to be clubbed with the P1. So this is the dendrogram of this cluster formation, right? So this representation is known as the dendrogram. Now here agglomerative can be done by using the complete linkage as well. So only one difference, the entire process is quite same, only one difference is there. Instead of the minimum distance, here we have to find out the maximum distance, right? From this point and this we have to calculate the maximum distance. Rest of the things will be as it is. We have to keep finding out. So instead of the minimum, now this time we have to find out the maximum, and based on the maximum value we have to merge 2 points together to form a cluster, right? So that is the idea. So if you move like this way, so ultimately this is the outcome of that. So these two values are very close to each other, maximum distance are there, so we are clubbing them together, followed by this one, followed by this one, and finally we are getting this this is the final outcome of that. Similarly, the another way is by using this average linkage. So in average linkage, so instead of minimum and maximum, this time we are going to be calculate the average distance, right? So the process is same. Instead of this, we have to find out the average distance every time. So this is the average distance, right? So that value we will update, right, in the matrix. And this is how this cluster will be formed as the final output. Okay, so that is the idea behind this agglomerative clustering and with the different linkage method. One more linkage method is there, and that one is known as Ward method, right? So in Ward method, if you see this Wikipedia, Ward method is a criteria applied to the hierarchical clustering analysis. Ward is a minimum variance method in special case of the objective. If you go through this, it will tell you the better understanding. I mean, you will get a better understanding of this. The sum of square start out at 0 and then grows as we merge cluster, right? So by using this method also we can form the hierarchical clustering, right? This agglomerative clustering can be happen. So this value basically we have to pass as a parameter. So this is the dendrogram representation of the single linkage. This is the dendrogram of the complete linkage. We can also have a average or Ward linkage. So now let us take one example. So here one of the data I took, that is a CSV comma separated value we are having, that we read by using this pd.read_CSV method, and the shape of this data frame is 200 by 5, right? So 200 rows are there and 5 columns are there. So to have a glance about this, I have used this head method. So here we are having this 5 columns we are getting. One is the customer ID. This should be gender, then age we are having, then annual income, and then spending score, right? So basically for doing this agglomerative clustering, I am taking this 2 column, last 2 column I am taking. So this is the data. This is the data corresponding to this last 2 column that we are having. Now we are applying this hierarchical clustering. So this is available in SciPy dot cluster dot hierarchy. So from there we are taking this. So this method, this class we are calling this. This is this method is available in SciPy. So from there we are calling it. Now let us plot this dendrogram. So here, if you plot this dendrogram, so this is how basically our dendrogram will look like if the method is called, right? So now the why we are drawing this dendrogram. So basically the purpose of that is to find out the how many cluster it may have. So by seeing this dendrogram, you may understand that this cluster, is going to be have a 5 different cluster. If you take a line and draw it parallel to x-axis, so you may get this 5 answer. So basically this data is going to be have a 5 clusters. So that idea you may get just like a k-means. In k-means also we were having a algo methods, right? From there we used to get the value of k. Similarly here by using this dendrogram, we can find out the value of k. So here we have to give this 5 value because 5 should be the number of cluster for this data, and then distance is Euclidean, and this time linkage we have given as a bar. So this is how this data point will fall down in a different clusters. So if you plot it, this is the final outcome corresponding to the data which we are having. So see how beautifully these results are appearing, right?
Thank you.